Yeah, I think I'll just go ahead and get started then. So my name's Chris Cornwell. I also am a PureScript developer at CitizenNet. Today, I just wanted to talk a little bit about the implementation of lenses in PureScript. First off, has anybody in here had experience using lenses in PureScript? Okay, and what about ProFunctor? Is everybody pretty familiar with ProFunctor and how that works? Has anybody dug into the internals of lenses and seen how it's actually working? Okay, good. So this should be new to everyone. And the reason that I wanted to give this talk is because just a few months ago I finally had a reason to use a lens in our code, and I wanted to actually understand what it was doing. And so I looked at the type signature of the functions and that sort of thing. And usually one of the nice things about functional programming is that, especially in pure code, you expect that you should be able to pretty easily reason about what's happening. Like if I call a function, I can look up the signature, I can look up how it's implemented, and I can pretty easily go okay, well, I get how that's taking my input and giving me this output. But when I try to do that with Lens, I did not have that experience at all. It was just something that seemed totally magical to me, and it was not clear. And so, like any good functional programmer, I busted out my pencil and paper, and I just started writing down these functions and substituting in the terms and looking at how the type aliases mapped. And it very quickly kind of ballooned, as you'll see, into this ridiculously complicated thing. And it was kind of overwhelming. But when I just kept pushing through it, eventually at the end, it all sort of comes together in this really, really beautiful and impressive way. And I think I actually, when I finally got to that point, I was at my desk and I literally just dropped my pencil and I was like, oh my God, that's beautiful. Forrest can attest to this. He was sitting right next to me. He was like, what are you doing over there? And so with that, I will start diving into how these things are actually implemented. So the first thing we can look at is, so what does it look like to actually use a lens? So the first thing you do is you make a lens. And in this case, for this example, I'm just going to focus on a lens that will work with a specific label on a record. And you can use this lens to get the value at that label out of the record. You can use the lens to set a value. And so for record, you use this function prop, which is from data.lens.record, and you pass it an S proxy or a symbol proxy. And for anyone who's not super familiar with how proxies work and what symbol proxy is, it's essentially a value level representation of a symbol, which is a type level string. But if that doesn't really make a lot of sense to you, you can really just think of this as, this is the label in the record that I want this lens to focus in on. So you can see I'm passing the label foo into this prop function, and it's going to give me out a lens. And that lens is going to act upon the foo label of some record. And don't worry too much about the type signature for lens. We'll look more into that later. So if we look at how we actually use this lens, I have this foo record, and foo record just has a foo label and a bar label. And I want to update that record by just calling show on the value of foo. So I make my foo record prime by calling this over function, and over is going to take our foo lens and the show function and my original foo record, and the output of that is going to be a new record where foo is now string 9000. And all the other labels are just going to be left alone. So bar is still false. So let's take a look at what this over function is doing. So over, we see it's a function. It takes a setter, which is a type of lens, which we'll get to. It takes some function. In our case, I passed in show. It takes an S, which in our case is the foo record, and then it outputs a T, which is the updated foo record. And S and T in this case are actually different types, because the function that I'm calling show is changing the type of the foo label from int to string. So it doesn't have to be. I could just pass in +1 as my function, and it would just add 1 to it. But over is general enough that you can actually change the type of the thing that you're working on. So well, this doesn't really tell us a whole lot. So let's see, what is this setter thing? Okay, so setter is a type alias, is parameterized by 4 type parameters, STAB, and it's an alias for optic function STAB. Well, okay, that still doesn't really mean anything. So let's drill down another level, and what is this optic thing? Okay, optic is a type alias for a function, and it's a function from PAB to PST. And in this case, P is totally general. P is still just whatever. It just is some arbitrary type constructor parameterized by 2 types. In practice, in this library, it always ends up being a functor, or a profunctor, but in this case, it doesn't have to be. And so if we start kind of substituting this back up, we see that if setter is a type alias for optic where P is function, then we can rewrite the signature, or what setter is an alias for, to function AB to function ST. So it's some function that maps between those two. And then, of course, we can actually rewrite that as actual functions. So we can see that setter is just an alias for a function A to B to S to T. Well, that looks kind of familiar. So if we look back at the definition of over, we see that over is, it takes a setter and then a function A to B and an S and returns a T. Well, that A to B to S to T, as we just saw, that is what setter is. That is setter. And if you look at the implementation, all over does is just return the lens that was passed to it. So in this case, over is literally not doing anything at all. And maybe it's just a holdover from the API with Haskell lenses. Maybe there's a reason for this, but you actually don't even need over. Like, I could just drop over out and just pass show directly to my lens, and it works just the same. It compiles and it just works.
Can you show the setter definition again?
Yeah. Yeah, so setter is literally just a type alias for everything that comes after setter in this function.
Oh, A to B, S to T.
Yeah.
Oh.
So all it's doing is just returning the lens. So this, again, doesn't really tell us much. Over is literally not doing anything.
So setter is an optic.
Yes.
Okay.
Setter is an optic where P is specialized to function.
Okay. And like I'm guessing there's also a getter, which is an optic, yeah?
Mm-hmm. Yeah.
Optic here means that you can...
Optic is just that alias for PAB to PST. And P can be all kinds of different, well, it can be anything, but it in practice ends up being all kinds of different profunctors. Yeah. Does anybody have any questions about this so far?
I wonder why setter exists. Why not just use the optic type alias?
I think it's just for clarity.
Yeah.
You know, if you say a function takes a setter, it's easier than like writing out the whole thing every time. Because it literally is just an alias. You can substitute those in freely, and it's exactly the same thing.
Specialized function.
Right, yeah.
Optic is
Specialized function, but there are
Yeah,
other optics that
there are lots of other objects, and we'll see another one in a second here. Okay, so like I said, so over actually isn't doing anything. This doesn't tell us anything about how this is working. So obviously all the magic is wrapped up in this setter, in the lens type. So let's look at what happens how we make this lens. What happens when we call this prop function? So this has some gnarly Rokon stuff in here that I'm not going to go into. If you're interested in it, maybe we can talk about it afterwards. But the important bit of this is that this function takes a symbol proxy, which is the label, and it's going to return you a lens that's going to operate on records that have that label. And if we look at the implementation, we see that you pass it the label, and then it internally calls this function lens. And it's passing lens two arguments. The first argument is just the get function from data.record. So get takes a symbol proxy or a label, and then you give it a record, and it will give you out the value at that label in the record. And then the second function is just a setter. It's basically calling the set function from data.record, and it's giving it the lens, or it's giving it the label, and we flip that just for the way that the ordering works later on, but set is just a function that, given a label and a value and a record, it's going to update the label on that record to the value. So let's take a look at what is this lens type alias. So lens, again, is an optic. It's a little more general than setter. It's a lens, or it's an optic where P is just constrained by this strong type class. And if we look at what the strong type class is, strong is a subclass of profunctor. I think that's the right term, subclass. And anything that implements strong has to have or anything that has an instance of strong has to implement these two functions, first and second. And first and second just lift a profunctor over the first or second element of a tuple, respectively. So to make that a little more clear, we can take a concrete example and see how is strong defined for function. So the first function for function is defined where you give it a function and you give it a tuple, and it just returns a new tuple where the function is applied to the first element. And then second does the same thing, it just applies that function to the second element. And so you can see second is actually just defined here in terms of map because tuple A is a functor. So if you map a function over a tuple, that's what it's going to do. It's just going to apply that function to the second element of the tuple. Okay, so that...
Back to the constraint.
Yeah.
You see strong. Okay, so we have a constraint, strong P for lens. So it's not function anymore, it's this strong.
Yeah.
To be strong, you have to have this first and second, which operates specifically on top of it.
Yeah, it strong first and second just lift a profunctor over a tuple, over the first or second element of a tuple. Okay, so that shows us, so that gives us a little bit of insight about what the lens type alias actually is. Let's take a look at what this lens function is doing. So this is the function that prop was calling internally. And so we see it takes a get and a set function, and it returns a lens. But internally, it itself calls another function called lens prime. And so you can see we just keep like getting kind of deeper and deeper in here, but we're not really any closer to understanding how this thing is actually transforming the record that we give it. So we can see that lens is calling lens prime, and it is passing it this function. This lambda right here is a function from S to tuple, where the first element calls the getter on S, and the second element is then a function that, given a value, calls the setter on that S and with the value. And so if we kind of start substituting some of this stuff down, we know that we call prop with this label foo. And so prop is calling lens, and this is what prop is actually passing into lens in our case. And to simplify it a little bit, we can rewrite this using PureScript's really nice, convenient record syntax. So the get can be rewritten as _.foo, which is just a function that, given a record, is going to pull the foo label off of it, pull the value there. And then this is like the record update syntax right here, where these two lines are equivalent here. So this is now a function that, given a record and then a value, is going to update foo on that record. So rewriting it like that is just going to help make it a little bit more concise for when we start substituting these terms down. So we see that now lens calls lens prime. So if the get and set function that we're passing to lens is up here, that's what's going to get passed into here and here. And so we can substitute that in here, and we see that what lens is doing in our particular case is it's calling lens prime, and it's giving it this function. And so you can see that this is actually just substituting those terms in directly, just to make it clear that's what's happening here. But we can simplify this. We can rewrite this to be this, which is a little bit clearer, I think. So we can see that what's happening is we're calling lens prime, and we're passing it this function that's going to take an S, and it's going to return us a tuple where the first element is just s.foo, and the second element is this kind of set function that is still awaiting some value, and then it's going to update the foo label on the record S. Okay, so is anybody like totally lost? Does anybody have any questions? Is there anything I can clear up before we move on? Because I know this is like a lot. There's a lot of substitutions happening and a lot of stuff going on. But if everybody's good, I'll keep going.
Can I see the lens type again?
Let's see.
Like,
Yeah.
okay, this is just the optic types.
Yeah, and again,
Setter was.
yeah, similar. And so this could actually be rewritten as, PAB, as where lens is a function from PAB to PST, where now instead of being a function, P is just constrained by this strong type class.
And why is that first and second function from the strong type class? Why is that necessary in order to implement this?
We will see that as we continue to dive down deeper into, actually once we show the implementation of lens prime, that's where first is used.
Okay, so we haven't used that constraint.
We haven't used that yet.
Well, we have used tuple, which is presumed by that constraint, like the output by that.
You're starting to see tuples in the implementation here. So yeah, so lens is calling lens prime, and it's giving it this function that's going to ultimately, the output type is a tuple. So we're starting to kind of see maybe how this stuff will come together, or at least why it is going to be important to be able to lift a function over a tuple.
Was there a function before this lens prime?
Yeah, there was. So lens. So if you remember, the function that we called to actually generate the lens was called prop, and prop called lens, and then lens calls lens prime.
Okay.
So like where we called.
I always get confused whenever I see the tuple in here, and I can't understand why the tuple is there.
Yeah, it is. It's like at this point, it's like, oh my God, what is going on here? Why is this so complicated? But it ultimately does, I promise you, come together in a, like, at least in my opinion, a very satisfying way.
Okay.
So this is where we're at now. We're calling lens prime, and this is what we're passing into it. We're passing in this function.
This returns a tuple with the value as
Lens prime, the function lens prime returns the lens. But what we're passing to lens prime is a function that is going to take, in our case, it's going to take our foo record, and then it's going to output this tuple.
Okay. Okay.
So the next thing to look at is, all right, so what is this lens prime function? Let's go another level deep. Lens prime. Lens prime takes a function of the form that we just saw, where it's S to tuple, and it returns a lens. And this, when I first looked at it, it was a little confusing because it looks like the type signature and the function definition are out of sync here. Because you can see that the type signature just says that this takes a function and has a return value, it returns a lens. But the definition is here, it's being given two arguments. And the reason for that is that if you remember, lens is actually an alias for a function. So if we substitute that out, we see that what the actual definition here is it takes a function of that S to tuple that we were passing in from lens, and then it takes some PAB and returns a PST. That's what this PAB is. And at this point, P is just constrained by strong. And then, so lens takes this 2 function, which is the one that we passed in, lens prime. The 2 function is the function that got passed in from lens, that S to tuple A, B to T. And then PAB, we're still not super clear on what that is exactly. So if we substitute in the 2 function, we see that in lens, this is what lens's implementation was. So it was calling lens prime, and this is the function that it was passing in. And so if we substitute that in, then we have this partially applied lens prime, where we've substituted in this function in place of 2. And this is where we're at. But if we remember, this is the lens. This right here is the lens, because lens is a type alias for strong P, PAB to PST. So this right here is what was output by the call to prop. after we gave it the symbol proxy or the label to the record. So yeah, so this is a lens, and this dime-map function, we're going to get to that in a minute. That's profunctor. So
What is the second? So we have the first one is the function that we passed in.
yeah, this is just a function that is defined here as part of the definition for lens prime. It's a function that takes some tuple and then applies the second element of the tuple to the first element. And then the third argument to dime-map is this. It calls first on PAB, which that's why we need the strong instance, because whatever that PAB is, we need to be able to call first on it.
So I've always thought of the lens as a setter and a getter, right? Like setter and getter pair.
Mm-hmm.
So like, is there like I kind of see a setter there, right? Like the lambda s to a tuple something, right?
Mm-hmm.
Is this all? Can we think of this as another encoding of a getter and setter?
Ultimately, it does end up being that. I don't know if that's the case for all lenses, because this is like a specific case where the lens is operating on a record. So if you have a lens that's operating on something like a sum type, I'm not exactly sure if it makes sense to think of it in terms of a getter and a setter. It might. I haven't really dove too much deeper into all the different variants of lenses. But yeah, absolutely. In terms of a record, I know for sure you can think of this in terms of a getter and a setter pair. And we'll see how it actually like puts all this together. So if we look at what happened here, so like I said, the output of this lens prime function, that is our lens. So this part right here, this dime-map function, that's what underscore foo is. And so if we pass underscore foo to over, we remember all that does is return underscore foo. And so then the next thing that we're doing, we're passing show in. So show is our A to B function right here. And so what happens if we apply that? What happens if we substitute that in? All right. So if you remember, so show becomes our PAB, and we're going to pass show to first. And first is defined for functions as just applying that function to the first element in the tuple. So what we get, instead of the last one here being first PAB, that becomes a function that takes some tuple and applies show to the first argument, or the first element. So this is where we're at now. So now what we have is we have this partially applied lens prime where it's just awaiting some input record, and it's going to give us an output record.
Can you go back once?
Yep.
A second? Oh, so the show went to F?
Yeah, show went into PAB.
Okay. And then first of show, we'll put the F, show becomes the F then?
No, show becomes PAB. Because if you think about this, like all this right here, like this, is foo. So foo is a function that's awaiting an A to B and a record, and it's going to give us out a record, right? So we pass show into foo, and then we'll pass foo record in there. And so show becomes our A to B, which is our PAB. So if we substitute that, PAB goes here, right? So PAB just gets passed to first. And if you remember the implementation for first, it just applies that function to the first element. So all I'm doing is now we have a function that's going to take some tuple and apply show to the first element.
How close to the bottom of the rabbit hole are we?
We are very close now. The last thing to look at is going to be profunctor and the implementation for dime-map. So dime-map is a function where given some A to B and some C to D and some PBC, we get out a PAD. Now, it's a lot easier to conceptualize that in terms of a concrete example, in terms of probably the most common profunctor that anyone's ever worked with, which is function. And so for anybody who's unfamiliar with profunctor, just really quickly, a profunctor is basically so it's parameterized by two type arguments, and it's contravariant in the first and covariant in the second, which means that it consumes elements of the first type, and it produces elements of the second type. And that is probably easiest to reason about in terms of a function, right? And we saw earlier how function, like you can represent A to B as function AB. And so A is the contravariant, where your function A to B is consuming A's, and B is the covariant, where it's producing B's. And that's what our show function is, right? Our show function in this particular case is consuming ints and is producing strings. And if you look at the definition of DIMAP for function, it literally just produces a big chain of composition, where you originally have your function B to C, right? And so when you DIMAP it, you take some A to B and some C to D, and you just chain that together. So you originally had a B to C, and now you have an A to B, which you compose with your B to C, which you compose with your C to D, and what you get out is a function from A to D. And so if you think right here of, if P is function, you go from a function from B to C to a function from A to D. You basically run your input all the way through that chain, and you get out your D. So now we can start thinking about, okay, so if we apply DIMAP then the result of that, so we passed in these three functions, and so the result of that is, you remember, you basically take the first function and compose it with the third function and compose it with the second function. So in here, the result of that you can see down here is we took our first function and we composed that into the third function, which was originally first, calling first on show. And then we finally composed that with our second function, our last function. And for the particularly astute viewer, you might be starting to see how this is going to come together. But we're going to walk through the rest of it. Okay, so this is our function, and it's going to take a record. It's going to take our foo record, and it's going to output the updated foo record. So what happens when we do that? What happens when we pass our foo record into this function right here, this big function chain? So the first function is the one that came in from lens. Is this function that's going to take an S, which is in our case our foo record, and it's going to output a tuple where the first element is s.foo, or 9,000. And the second element is this function that's going to take some value and update foo to be equal to that value. Okay, so now we have this tuple, and we're going to pass that into our second function. Our second function, as we can see, it takes a tuple, and it applies show to the first element. It applies the function that we gave it to whatever the first element was. And so if we apply that, then we take our tuple 9,000 b to whatever, and we output a tuple where we call show on 9,000. And so the result of that is a tuple where the first element is string 9,000, and the second element is still our same function. That wasn't touched in that process. And now the last thing that we do is we take that tuple and we pass it into this third function. And what that third function is going to do is it's going to take the second element, which is a function, and apply it to the first element. And when that happens, we basically apply that in. So it's going to take our tuple bf, which is tuple string 9,000 b to blah, blah, blah. And so when we pass that in, we take that function, the second element, the b to this stuff, and we apply it to the first element. So the result of that is going to be a function, string 9,000 to foo. If we substitute that in, then what we have here is this expression, where 9,000 gets substituted in for b, and now we have a function, or now we have just like a simple record updater that's going to update this foo record with this to set foo equal to string 9,000. And then finally, the output of that is our foo record prime. That's what we wanted from the beginning. That's how we called show on foo and got a new record out of it. And to me, like this was my reaction to kind of seeing all that magic come together at the end. I was like, what is going on? This is amazing. And you might be thinking, this seems like a ridiculously complicated and convoluted process to go through for something as trivial as updating a value on a record. And you're absolutely right. If that's all you needed to do, then you should just use PureScript's record update syntax because it's super concise, it makes perfect sense, it's really easy to reason about. But as soon as you need to do something significantly more complicated, really kind of like drilling down into nested structures, or maybe you need a lens into a sum type, into a record, into unwrapping a new type, into another record, and into an index of an array, blah, 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 whatever you need to do, that kind of stuff is where I think all this complicated internal machinery actually does become necessary. And using lenses is just so ridiculously powerful, and it's cleaned up our code in so many places that it's really cool.
How does using lens make that easier, like updating nested structures?
So one example that I did actually include in here, this is one of the places where we are actually using a lens. So one way that it makes it easier is these lenses, since they're all just functions, you can compose them together. And so right here you see on one of we have some list views where we pull data from the server, and our list is paginated. And so we keep that paging information on our state. But we represent our data that's coming from the server as this remote data type, which I think is just like network or data.network or something like that, which is nice because it just has these, it's a sum type, it just has these 4 data constructors. It makes it really easy to represent remote data, where it's like, if we haven't asked for it yet, it's in the not asked state. If we made the call, but we're still waiting to get it back, it's loading. If the call failed for some reason, that's an error or a failure. And then only in the event that we actually got the data back successfully is it a success. But the data that we're getting back from the server includes the paging data, right? Because we need to know what was the count of items that came back from this query, how many pages are there, what page are we currently on, that sort of thing. And so that paging information is wrapped up inside of this remote data type. But when a user, for instance, clicks on the little paging widget where they want to advance to the next page, or they want to go to page 39 or something like that, we need to be able to actually drill down into that structure. So how it's actually represented is we have a remote data, and inside that remote data is a record, and that record has a paging key on it where the paging data is. But we actually, maybe unnecessarily, represent our paging data type as a new type wrapper around a record that has all this stuff in it. And so what this actually does, and this is an example of using lenses to drill down into sum types in a really effective way, because what we're saying here is we're gonna get, basically when they click the button, we take the page, whatever page they want to go to in. And so we're going to get the page teams key off of our state, which is the key that has this remote data. And then we're going to map that over. We're going to set, and then the lens that we pass into set is this thing right here. So first we're gonna, and this success lens is one that's exposed by the remote data library, and it's particularly useful for updating it like this. So the lens is, it's gonna look for the success data constructor and remote data, and then inside of that it's gonna look for the paging key, and then inside of that it's gonna unwrap the new type, and then inside of that it's gonna get the page key out. And so that's our lens. We pass that to set. Set is basically like over, except you're not passing it a function to update the value. You just say, this is the value, set it to that. And so this is kind of similar to what we already did. This is our lens, and this is the value that we want to set it to. And this is our data type that I'm mapping it because when you call h.gets, it's wrapped up in like the state monad. So we're mapping it over that. But ultimately, we're pulling the key off of our state, and it might be a failure, right? It might be loading, it might be not asked. And in any of those cases, this whole process just kind of conveniently returns whatever it is. But if it is a success, then this is gonna drill all the way down into that nested structure, and it's gonna set the page to be whatever the user selected. And then because it's either going to be what it was if setting a page is just not a relevant action to take, or it's going to be updated. All we have to do is just modify the state to set that key to whatever it was, and then we call our eval, which then pulls that off the state and makes the API call and everything. So that's just one example of how having to unwrap pattern match on this data constructor and then do like dot key and unwrap the new type and get the page. I feel like this is just kind of a nicer way to handle that. And we have some other examples too of like drilling down into arrays and pointing to specific indexes and things like that.
So the h.gets is an asynchronous thing? And that,
No, h.gets is a halogen. It basically just pulls your state off of it pulls your state out of them, because this is all happening in the context of the eval function, which is all happening inside of the halogen monad. And so h.gets is a helper function exposed by halogen to just get your state. So h.get will just pull the whole state off. h.gets allows you to pass something like this record get, and it will pull the state and then pull whatever key you asked for off of that state.
It's actually just a re-export of the state monad. Get. Gets.
oh, yeah.
So that's all I've got. Does anybody have any questions?
Where do you use this to improve your code base?
Where would I use?
You mentioned that you used it to improve your code base quality.
Yeah, I mean, this is one example right here where if we were to do this without lenses, we would basically have to case on the data constructor of the remote data, and if it was success, then inside of that we would have to pull that. Then it would be what would be wrapped up in there would be a record, and we would pull the paging key off of that, and then that would be a new type, so we would have to unwrap the new type before we get in there. This is just a much more succinct, I think, and cleaner way to accomplish that same thing.
We had a view that was like a rolled up view, so we got a flat list of stuff, but we basically roll it up to like nested view, or you get like a flat list and it's like, okay, well, group it by this, and then group it by this, and then group it by this, where you want to maybe make an update in like the third level. Like the lenses work super handy to basically go like, at this key, at this index, at this key, at this index, update this key.
Yeah, the fact that you can just compose them together like this to really drill deep down into these nested structures is really when it becomes super, super powerful.
That's funny. I have the same exact remote data thing and code that I have. And I didn't use the lenses, so I had to basically compose I derived new type, and then I'll under I don't know which function it is. Yeah, I have like fmap over my possible data structure and do some weird shit. It's not very nice.
Yeah, this is much nicer. When I discovered that success, that they expose those lenses for each of the data constructors, and those are something else entirely. I haven't actually gotten into that because those are, instead of strong, the constraint is choice, and that's specifically, I think, more for like working with sum types, where I'm not exactly sure how that works, because a set on that makes sense, right? I want to set the value inside of this particular constructor. So if it's not that constructor, it's just going to return you whatever it currently is. But the get, I'm not exactly sure how that would work. It seems like you'd have to maybe provide a default value or something, because like, what if it's just not a success? Like, what are you going to get out of it if it's not a success? So for some types, like, I think prisms, yeah, prisms work on some types, and I think that's what success is actually.
Yeah, they pull back maybes.
Oh, it's maybe. So if you do get on a prism, it's a maybe. That makes sense.
I've heard that the Thermite library for UIs, it's like wrapped around React, but it uses lenses a lot there. Have you looked at it at all? Like,
I haven't really worked with Thermite or spent a lot of time looking at it.
As I understand it, the way that it helps out there is that it lets you focus on just a part of a child component state or a parent component state. It helps there, so you don't have to know the entire state of a related component. You just know a part of it and embed that in somewhere.
Yeah.
Is the reason that pro-pointer lenses work in PureScript because the record types can change and we don't have that in Haskell? That's why that
I bet that has something to do with it. Yeah.
I saw the types change. I'm like,
Mm-hmm.
you can't do that in Haskell.
Yeah, the fact that they have these kind of polymorphic row types where you can have like your input record have a totally different type than your output record, and you can also like alias them, I think, in ways that you might not be able to in Haskell. I don't know. I'm not super familiar with Haskell other than what I've learned here in the last 5 days.
A label in a row.
Well,
Mm.
you're producing a record of a different
Different
type.
type, yeah.
Yeah.
That's pretty powerful.
Yeah.
I'm not super familiar with how they do it in Haskell. I know that there's like a different set, like there's a different way to do lenses in Haskell. There's like for
Mm-hmm.
So instead of like, they'll like has name, which includes name, and then that's a type class which infers automatically. So you don't use your excessive, you use your ad hoc polymorphism of type classes. That's all code gen.
Have you looked at the generics lens library?
I have not. No.
Wait, for PureScript?
I think there is one, yeah. So if you don't want to refer to a specific constructor by name, you just say the first constructor or something.
I don't know. I'll have to look at it.
Too much.
Yeah.
Too out of my league.
they're not now.
Yeah. So it kind of troubled me that I couldn't just like look at that initial type signature for over and for prop and just see how this was working. So I stepped through all this stuff, but then at the end I was so stoked when I was like, oh my god, that's beautiful.
A more appropriate question for you for this is the propunctor and the strong constraints on these lenses, right?
Mm-hmm.
This is only instantiated. The only instance used for this is the function type.
In this
right?
case, yeah, for over.
Have you considered any other types of strong propunctors that we could use in this case?
I think the library only implements function. I think that's the only implementation. Like,
Yes, function is the only profunctor that I know that
Any
implements
strong
function.
propunctor you have,
Yeah.
you could just make a lens into it.
Yeah.
Right?
Yeah, you could.
I see like the Mealy machine library has a strong instance,
Mm.
like the Mealy machine type. So maybe you can put a lens into it or something. I don't know. It's interesting.
Yeah, I don't know. I'd have to look into it. I'm not familiar with that library.
General question, do you think you could use lenses to construct a data structure, construct the structure of a data structure from scratch? Say you had default values or you were defaulting to empty substructures, that sort of thing. You had a series of lenses and use them to build up that structure from scratch.
That's an interesting question. I don't know. I haven't really thought about it. In terms of something like a record, maybe. Like if you had like a specific set of labels that you wanted in your record, using a lens to build them up. I'm not exactly sure how that would work. I mean.
You probably have to use some combination like composition of builder.
Yeah, that's what I was thinking. Like for record in particular, I'd probably reach for builder in that case to actually like create the structure. I'm not sure about that. My intuition is that lenses are mostly going to be used for like accessing properties of existing structures, but you could be able to do that. I haven't looked into it. All right. Well, thank you, everybody.